Hello students of Year 11 Maths General, and welcome to the second exercise 4J video, which is about the elimination method for solving simultaneous equations. At this stage, you should already have watched the substitution method video. Now, to understand the elimination method, we need to know a few facts about equations and the types of things we're allowed to do to them. Now, something that is true that you may not know is this first piece of information on the slide here. It says that whole equations can be subtracted or added to each other. So what I mean by that is, for example, I could have two equations and I could say equation 1 plus equation 2. And what that means to do is to create a new equation that has the form that's written down here. So on the left-hand side of the equals sign, so all of this stuff, what we'll have is, if I'm adding the equations together, what I'll have is the left-hand side of equation 1 plus the left-hand side of equation 2. That's what will be on the left-hand side of the equals in this new equation. Then on the right-hand side, as you might have guessed, I'll have the right-hand side of equation 1 plus the right-hand side of equation 2. Now, that's true as well for subtraction. So if I did equation 1 subtract equation 2, then I would have everything the same here, except instead of my plus signs, I would have minus signs. I would have subtraction signs. So it would be left-hand side of equation 1 minus left-hand side of equation 2 is equal to right-hand side of equation 1 minus right-hand side of equation 2. Now, as always, this might sound like gibberish. You might not understand exactly what I'm talking about right now, but once you see the example questions, it will begin to make sense to you, I promise. Now, the next thing that we need to remind ourselves is that equations can also be multiplied or divided by numbers on both sides to change the coefficients of certain variables. So usually, the way we've done that so far is if we've had 5x, for example, on one side of an equation, we've divided both sides by 5 in order to cancel the coefficient, because 5 divided 5 is just 1, and then x would be on its own. That's not always what we want to do with our elimination method. We may want to change coefficients to things other than 1. So just remember that you are allowed to do that. So if I had 5x and I multiplied both sides by 2, I would end up with 10x. Now, in elimination method for solving simultaneous equations, that might actually be beneficial to me, it could be a first for you if you haven't seen this method before. Again, that will make sense once we see it in a question. So let's wait till then. Now, with the combination of these two moves, we can eliminate certain variables from equations in order to solve them. So let's take a look at what exactly I mean by that by just doing an example question. So here I've got the same equations from yesterday, y plus 2x equals 5, which I'll call equation 1, and 3x take 2y, which is equal to 4, and that's equation 2. Now, in these two equations, I have y's and x's are present in both of them. Now, what I need to do is I need to make sure the coefficient in front of one of the letters is the same in both equations. So what I'm talking about is the number in front of x has to be the same in both equations. So in these two, it's 2 and 3 respectively, so not the same. Or the number in front of y has to be the same in both of equations. And that's not the case for either of them. So what I'm going to have to do is I'm going to have to use one of the two moves that I was talking about before. And I can be a little bit creative here in terms of what I choose to do, but all I need to do is I need to make sure that the coefficient in front of one of the letters is the same in both equations. Now, looking at these two equations, the x's already have coefficients in front of them. So all I could do is perhaps multiply the first equation by 3 in order to change this 2 to a 6, and multiply the second equation by 2 to change this 3 to a 6, and that would get me to the same. However, there is an easier way to do this, because this y here has no coefficient currently. So that means if I multiply by any whole number, the y will have that new whole number as its coefficient. In this equation here, I've got a y whose coefficient is 2. So if I multiply my first equation by 2, I'll have 2y at the start, and my coefficients will match. So that's actually what I'm going to do. I'm going to say equation 1 times 2. So I'm not timesing equation 1 by equation 2 because there's no circle around it. I'm just multiplying the equation itself by 2. So what that means is everything in the equation gets multiplied by 2. So now I have 2y, because it's y times 2, plus 2x times 2, which is 4x. And that has to be equal to 5 times 2, which is 10. So this is my new equation, 2y plus 4x equals 10. And I'm going to call this equation 1a. Alrighty, now that I've got the same coefficient for y in both of my equations, I'm just going to do one more thing, and that's to change the order of my letters here to make them match in both equations. So in equation 1a here, I'm just going to change it one more time. I'm going to put the x's first. So it'll say 4x plus 2y equals 10. And that's equation, that's equation 1a, or 1b we'll call it now, because we have made a slight alteration to it. Alrighty, that's equation 1b, and now I'm just going to write equation 2 underneath it, which is 3x minus 2y, and that's equal to 4. And that's equation 2. Now, the reason I've done this is because it might help you to visualize what the working will look like. So what I'm going to do is I'm going to do equation 1b plus equation 2. Because when I do that, I have a positive 2y, and if I add negative 2y, positive 2y plus negative 2y is equal to 0. So I would be cancelling the y's out from the equation. And that's why we call it the elimination method, because by doing that, I'm eliminating the y's from the equation. So let's do that now. I'm going to do 1b plus equation 2. So equation 1b plus equation 2. So what I can do is I can actually put a plus sign down here and visualize the way this expression works. So 4x plus 3x is 7x. Oops, sorry. Now, like we said, 2y plus negative 2y is equal to 0. So those terms, those y's, they cancel each other out. So I'm left with 7x plus 0 is equal to 10 plus 4, which is 14. So 7x is equal to 14. Now, I can divide both sides here by 7 in order to get x on its own. And what I'm left with is x equals 2. So that's how we can get an answer for one of our variables using the elimination method. And now that I've got x is equal to 2, let's call that equation 3, and then we can simply use our substitution method from there to find out what y is equal to. So x is equal to 2. Let's substitute that fact into equation 1, because it's just a little bit of a simpler equation. So what that means is y plus 2. Now I'm replacing the x here with x equals 2. So y plus 2 times 2 is equal to 5. So y plus 4 equals 5. Alrighty, subtract 4 from both sides, and y is equal to 1. So therefore, my answer is x equals 2, y equals 1. So now that we've taken a look at an example question, let's just have a look at the instructions or the process that we need to work through every time we use the elimination method. So the very first thing we need to do is to make sure that one of the variables has the same coefficient in both of the equations. So either the x in both equations has to have the same number in front of it, or the y in both equations has to have the same number in it, or whatever letters that the given equations have, at least one of those letters must have the same number in front of it. We can make this happen by multiplying or dividing one of the equations by the right number or numbers. Once we've got that, we need to use our second step. We need to add or subtract one equation from the other in order to make the variable that has the same coefficient in each equation cancel out. Then the third step is to solve the resulting equation from there using algebra, and then use the result of that to find the value of both variables. So once I do my elimination method, what I'll be left with is one equation with one unknown. Whether that's x or y or another letter, I have to find what that variable is equal to. So I need to find x equals 4, for example, and then I can substitute that into another equation to find the value of the other variable. Now remember, with simultaneous equations, you're not finished until you find the value of every single variable that you can. So if it's x and y, you have to find both x and y. If it's a and b, you have to find a and b. You don't just stop after you find the first one. Alrighty, thank you, Year 11, and good luck with these textbook questions on the elimination method.